Hey students, in this video we're going to cover isosceles and equilateral triangles. So our objectives are to learn terminology and notation related to isosceles and equilateral triangles, and we're going to use algebra to solve various kinds of problems that involve isosceles and equilateral triangles. So first, some notation. An isosceles triangle is a triangle that has exactly one pair of congruent sides and it has a base. The angles that are formed by the congruent sides and the base are called base angles. The angle opposite the base is called the vertex angle. So, let's go back. So if we're going to start doing this kind of thing, and let me lock my orientation. There we go. All right. So we're going to start doing this kind of notation where this is my pen on. No, it is not. Hold on a moment. Let me sync my pen. There we go. All right. So we're going to start using this notation where we have from this angle, I'm drawing an arrow. This angle is opposite this side. So where I'm drawing the arrow is the side that is opposite a particular angle. So we see that the congruent angles match the congruent legs, and the vertex angle is across from the base. So if you know one angle in an isosceles triangle, you can always find the other two angles. That is not true necessarily for the sides without trigonometry. So let's go. So in this first example, we have to find the missing value of x and y. Now, because the triangle is isosceles, we know because let's label our sides. We'll call this side A, side B, and side C. You know what? Actually, let's be even better geometers. So let's say we have a triangle and we're going to call that A, B, and C. Based on how we labeled our triangle, we know that segment AB is congruent to segment AC. And because of that, we know that angle B should be congruent to angle C. So that means that Y has to be 66 degrees. Based on the triangle sum theorem that we did last class, we know that 66 plus Y plus X should equal 180 degrees. And that's because those angles are interior to a triangle. So we already know that Y is 66. So 66 plus 66 plus X should equal 180 degrees. So that's what? 132 plus X equals 180. And we subtract 132 from both sides. We get X is 48 degrees. So we know X is 48 degrees. So that's it. Given one angle in an isosceles triangle, you can find the other two angles. The second example is we have an isosceles triangle and we have two given sides and we want to find the value of X. Now, we know the triangle is isosceles because we have a pair of congruent angles. And the angles, remember the angles are, you can just draw an arrow to find the sides that have to be congruent. So we know that 2x minus 5 should equal 9. Now this is going to be easy. So we get 2x equals 14, divide both sides by 2, and we get x equals 7. So obviously 2 times 7, which is 14 minus 5, is going to give us 9. So we know that, again, our value of x is correct. For example 3, we have an equilateral triangle. We know the triangle is equilateral because, let's label this, we'll say A, B, and C again. We know that AB is 7, and we know that AC is 7. So the implication is that AB is congruent to AC. That indicates that we have an isosceles triangle. So because the triangle is isosceles, we know that this angle X and this other angle, we'll call that angle Y or angle ABC, however you want to call it. They're congruent. They're congruent base angles. So you know what? We don't actually have to call it angle Y. Let's go back a moment. Because the sides are congruent, so let's mark them as congruent. This side is congruent to this side. So we know that this angle and this angle are congruent. So that means that this other angle is also x degrees. So the equation that we could make is x plus 80 is equal to 180 degrees, or 2x plus 80 is equal to 180 degrees. And so 2x equals 100, and dividing by 2, we get x equals 50 degrees. So x is 50 degrees. Fantastic. All right, so that is how we solve an isosceles triangle, only given the vertex angle. I should have mentioned that. My apologies. 80 is the vertex angle because it's not across from one of the congruent sides, and these two angles are our base angles. So x and this other angle x are also our base angles. Next, we have an equilateral triangle, which is the same as an equiangular triangle. And in an equilateral triangle, all of the angles are congruent and all of the sides are congruent. So since all three angles are congruent in an equilateral triangle and the three angles have to add to equal 180, each angle in an equilateral triangle always has a numerical value of 60. That's not to say we won't have algebraic expressions, but the numerical value is always going to be 60. And the sides are always all going to be the same thing. So, for example, 4, we have an equilateral triangle, and we know that because the three sides are all marked congruent. So this is pretty straightforward. To find the values of x and y, we know that because one side has a numerical value of 10, the other sides also have to equal 10. So we can say x equals 10. So we already solved for x. And we know that y plus 3 also has to equal 10. So then to solve for y, we just subtract 3 and we get y equals 7. So we know x equals 10 and y equals 7. And each of the angles is going to be 60 degrees because it's equilateral. For example, 5, we have to find the values of x and y. And again, in an equilateral triangle, we know that each angle is 60. So that even means that the 4x degrees is equal to 60. So if we solve the equation, 4x equals 60, then we get x equals 15. And we know that y and 60, they form a linear pair. So because they make a straight line. So we know that y plus 60 equals 180. And so y is 180 minus 60, which means y is 120 degrees. We could have also used the exterior angle theorem to find to find y, because since y is here, we know y is the sum of the two remote interior angles. So y is 60 plus 60, which is also 120. But either way, using the triangle sum theorem and linear pairs, we get y is 120. And by setting 4x equal to 60, we get x is 15. Our last example is we're solving for x and y. We know the perimeter of this triangle is 54. So solving for y is easy. Because the triangle is equilateral, we know that y is 60. Or we could just do 60 plus 60 plus y equals 180. So that would be 120 plus y equals 180. So y equals 60. Now to solve for x, we know the perimeter of the triangle is 54. Because the triangle is equilateral, we know all three sides are congruent. which means that that side's 4x, this side is 4x, and this other side is 4x. So what we're solving is the equation 4x plus 4x plus 4x equals 54. And so that's the same as 12x equals 54. And we divide both sides by 12, and we're going to get x equals 4.5 or 4.5. So yes, it is possible to get a decimal. They happen all the time. So x is 4.5. All right, so that's, so we have two more examples, I'm sorry. So now we're putting a bunch of stuff together. So in this diagram, we have two isosceles triangles, and we need to find the value of x. If I were you, pause the video and see what you can come up with. All right, so if you're rejoining me, you know in this top triangle, we're given the vertex. It's the vertex angle of an isosceles triangle, which means that we'll call this angle y. These two angles are equal to each other. So we know that 2y plus 84 has to equal 180, and we can subtract 84. So we get 2y equals 96, divide both sides by 2, and we get y equals 48 degrees. So both of these angles are 48 degrees. So y equals 48. And let me get my eraser. Nope, did the highlighter. So we're going to get, nope, not highlighter, pen. So, nope, see, it's doing a highlighter. Why are you like this? So take that out. And let's go back to the pen. So we get 48 degrees for both. Now, something that has nothing to do necessarily with triangles is that here we have some vertical angles. And remember, vertical angles are congruent, so this angle is also 48. So now if we're going to find x, then x also has to be 48 because it's across from one of the sides that are congruent to each other. So we know x is also 48 degrees. All right, so for this last one, we have an equilateral triangle, and we need to find the perimeter as a numerical value. So because the triangle is equilateral, we can set any two sides equal to each other. So we could solve the equation 2x minus 3 equals 3x minus 11. So we'll subtract 2x from both sides. We get negative 3 equals x minus 11. We add 11 to both sides. So we'll do plus 11 plus 11. We get 8 equals x. So since x equals 8, we can substitute that in to see if we, now because x equals 8, we should get the same value for each side of the triangle. So here we're going to get 2 times 8 minus 3, which is 16 minus 3. So this side should be 13. Over here, we're going to get 3 times 8 minus 11, which is 24 minus 11, which is 13. So that works. And then we get 21 minus 8, which is also 13. So you should check to make sure your value of x gives you the same side length for each side. And so because we know all three sides are equal, we know the perimeter is equal to 13 plus 13 plus 13, which equals 39. All right, so that concludes our video on isosceles and equilateral triangles. A quick recap, I don't zoom on that. For an isosceles triangle, you have a base, you have two congruent legs. The intersection of the legs and the base, that makes our base angles, and then we have our vertex angle. And for an equilateral triangle, all three sides are congruent and all three angles are congruent, and they equal 60 degrees. All right, thanks for watching, guys.